record. All right, well, thank you everybody for joining us today for the March 2016 Globe SMAP Soil Moisture Field Campaign webinar. This looks like we have a great crowd today for our discussions and our presentations. And yeah, it looks like we have many countries involved. So if you can, please, in the chat box, put where you're from. Because like it doesn't all, some people put it in their name when they logged in, but in the chat box, just put it in there where you're from, and that would be great. It's great for our purposes, and it's great to know where you're from and where the participation is coming from. So that's excellent. So it looks like we have 19 participants today, which is pretty good. So thank you again for joining that, and thank you for, I see the things are going into the chat box. So it's been a great month so far. Sorry, I keep on pressing that, but it's been a great month. The month of February was great. We have a lot more schools that are participating in the U.S. and in other countries, and I'll go over that in a couple minutes. But today, what we're going to have, we have Dr. Erica Podest on, SMAP scientist from the Jet Propulsion Laboratory in Pasadena, California. She's going to talk a little bit about the SMAP mission, what's going on with it, and a little bit about how SMAP, when it was first launched, it's used its onboard radar to measure, to basically look at the freezing and thawing aspect of soil moisture. And then we'll have a little bit about some of the things that are on Globe right now, kind of a recap of what we talked about during our last webinar, but I know some people couldn't make it, so I want to go over some things that you might not have seen and that you might not have noticed on the Globe visualization map and things like that. So let's go ahead and get started, and we will first go to Dr. Erica Podest of the Jet Propulsion Laboratory. And as you may know from other webinars, but there are a lot of new people here, Erica is a research scientist with the SMAP mission, studying soil moisture at NASA's Jet Propulsion Laboratory. And I will turn it over to Erica.
Thank you, Brian, and thank you everyone for joining. As Brian mentioned, there's another product that's part of SMAP in addition to soil moisture. It's called the freeze and thaw product. And what this product tells us is whether the land surface is
Hey, Brian, can you hear me? We've lost your audio. Nobody can hear Erica.
Okay, Erica, your audio is out. Looks like I don't see here on the that she might have to join us back. So what I will do is I will go back to my screen and until Erica joins us back again, joins with us again. Sorry about that. Glitches happen. That just happens to be a glitch. So we will come back to that. What I want to discuss a little bit now is this is one thing we really highlighted on the last webinar, and this is all about when you do your live data entry for your soil moisture under the SMAP block pattern soil moisture protocol. There is a box there now that says soil state, And soil state, we added this because lots of schools in the Northern Hemisphere were having problems collecting the soil because either there was snow covered or the ground was frozen, or there was other types of precipitation on the ground as well. So under soil states, what you can do is, if it is measurable, if there's nothing impeding your soil moisture collection, it'll be labeled as measurable, and then you can go and add it normally, add your information normally, the drying method and all the weights and measures. If you,
Hello?
hey, Erica, you're back?
Hey, yeah, I'm very sorry. My connection dropped.
Oh, no problem. I will go back to that slide and then we'll come back to this one then, okay?
Okay. Sure. So I'll just pick up where I think I left off. I was talking about the freeze-thaw product, and we had planned to generate this product with the radar, but since the radar stopped working, now we're looking at generating it with the radiometer. So it's going to be a 36-kilometer product. And as I mentioned, it's a binary product. So we're assessing, it's a measurement on whether the land surface, the area that we're looking at, is either frozen or thawed. And you might be imagining, okay, so why is this important? It's actually very important to better understand the carbon cycle, for example. So when you think of vegetation, especially in the northern high latitudes, and those of you that live in northern high latitude regions and very cold regions know that there's a very strong seasonality. So when a winter comes around, vegetation freezes and the land surface, everything freezes. And during this period of time, there's a minimal exchange of gases of CO2 between the vegetation and the atmosphere, or the soil and the atmosphere. Now, when the spring comes around and temperatures go above freezing, then you get what the thaw begins at that point. And there's a huge surge of water, of liquid water in the land surface. So you've got snow melt and the tree thaws, and then the tree can draw water from the ground, and that's the beginning of the growing season. And during this period of time, which lasts until early fall, the vegetation grows. So during this period, it takes up a large amount of CO2 from the atmosphere and stores it in its leaves and its branches and its trunk. So that's what the biomass of the tree is made of. And so it takes up so much CO2 that it makes a difference in global CO2 atmospheric concentrations. So if we can better determine when this period begins and when it ends, then we can have a better understanding of the contribution of vegetation towards the uptake of CO2, vegetation in the northern high latitudes. And what you're seeing here in this chart, the blue areas are areas where the land surface is frozen, and that is in early April. And the figure on the right is in almost 2 weeks later, April 13th. And you can see that the red areas are areas that are thawed, blue areas are areas that are frozen. So the progression of the thaw has already begun during this period of time, and it's quite significant between the 1st of April and the 13th of April. So your measurements, you guys are measuring soil moisture, but you're also making a note whenever the soil is frozen, or whenever there's snow on the soil, on the surface of the soil. And that's extremely important to us for a couple of reasons. The first one is we can't get good soil moisture retrievals whenever the soil is frozen. So that really helps us then validate our measurements in that respect. You know, if we're doing retrievals over areas and the retrieval and where the soil is frozen, then we can really verify that through your measurement, through your note. And then the other thing is, since we don't have this this product that I mentioned, this freeze and thaw product, it's even more useful. Your observation of whether the soil is frozen or not, because then we can better assess the growing season length and when it specifically started and when it specifically ends. Okay. Hello.
Yep, that sounds good.
Okay, great.
Does anybody have any questions for Erica regarding this, the freeze thaw product and anything about your measurements that you've seen that you've not been able to take? Doesn't mean you put them as immeasurable because of frozen soil. If you have any questions, please you can unmute yourself.
When did Erica say, I'm sorry, Erica, when did you say the freeze thaw product will be online now with the radiometer as opposed to a radar?
Yeah, so that's in development right now,
Okay.
and we think it might be online later this year, probably around November, December. However, we do have a product that was derived from that 2.5 month period where we collected radar data, and that is already online at the NSIDC website, the DAC.
And you can get
Thank you.
You can get that information, the direct link to the DAC, if you go to the SMAP website. It's just smap.jpl.nasa.gov. And up in the top menu bar, there'll be a link that says data. You can click on the data. It'll open a page, and then there'll be a link on there that can take you directly to where the SMAP data is located on the NSIDC. It's a National Snow and Ice Data Center website. So you can grab it right from that website. And once again, that's SMAP. There's no www in front of it. It's just smap.jpl.nasa.gov. Okay, any other questions for Erica? All right. Thank you so much, Erica.
So, Brian,
Yeah.
this is Kevin. So, Erica, are you saying that this type of image that shows the frozen ground and the thawed ground, that'll be available in a couple months? Or because we're really interested in this type of information.
Yes, correct. It will be available in a couple of months. Since we had developed the algorithms to generate this product based on the radar data. So since we no longer have the radar, we're developing an algorithm to generate the product based on the radiometer. So that's why, it's still in development, and we don't think it'll be ready until later this year, November or December. But as I mentioned, the 2.5 months of radar data that we collected, there is a freeze-thaw product for that period of time. And then the one that's going to be available later this year will be from when the radar stopped working around early July through current.
Well, thank you.
You're welcome.
All right. Any other questions for Erica? I'll wait a second if you unmute yourself. All right, excellent. Thank you again, Erica. So on this slide, the slide that's up now, I also mentioned, and Erica mentioned as well, that you have the opportunity when you collect the soil moisture samples. If you're able to collect it, you check measurable as a soil state, and then you can go through the normal process of filling out the data sheet from the drying method to the drying time to all the weight measurements and the volume measurements. But once again, if your soil, if there's something that's impeding the soil, for instance, frozen ground, snow on ground, a grapple on ground, hail on ground, or frozen water on the ground, you don't want to collect your soil moisture sample. It will be considered immeasurable. So what happens is on the bottom here, if you click one of the immeasurable states, this box will come up. It'll say non-measurable soil state, and it'll bring up this dialog box with a comment section where you can add any comments about the soil, and that'll be then when you send it, that'll be entered into the GLOBE data system. As Erica said, that's very important. the immeasurable state of your soil at your location is very important for the SMAP mission as well. And it's very good because it shows us, when things, the patterns, when you were able to take measurable samples, and then all of a sudden, you hit a certain time of the year and you weren't able to take it because of frozen ground. And then once again, during the fall, when you can take the measurements again, we can see that trend, and we can look at that across the planet, especially of course in the Northern Hemisphere. So Globe Schools taking measurements. Here is the map. This is just in February. Since this is a March webinar, I figured I'd put up just the February. As you can see, we had some pretty good concentration of activity on the East Coast of the U.S., and we had a great school here in Boston, Montana. The teacher is online with us right now, as well as Croatia. No surprise there, so congratulations, Croatia, for all the great data collection. Marina from the Varazin School is online with us today as well. And we actually had a school in Israel started taking measurements, so we're very excited about that. So the map on the bottom shows basically 1 year of measurements, and you can see we have the great measurements across the world here. There are a couple that are a little off, and I've contacted those schools, but I haven't gotten any reply yet. The two that are in China, there's actually a latitude longitude issue that when they entered that into the site that was selected. And they are actually schools from the United States. It's just a latitude longitude problem when they set up their site, and we're working with that with them as well. So we have lots of participation coming in, and that's excellent news for this. And thank you everybody for the great data collection. So here is the everybody's favorite part, the data count. Since the launch of the SMAP satellite on 31 January, sorry, I should say 2015, my fault there, it should be 2015. There have been, as of when I took this information, this was end of last week, 1,260 SMAP protocol soil moisture measurements taken, 9 countries collecting measurements, and 67 schools at 94 collection sites. So that's very awesome data and numbers there. The soil states added as immeasurable do not yet show up on the Globe data map. Globe is working on this, and I know we're working hard to get this visible on the map. We'd also like to welcome a few new schools and countries. We have a school in Thailand, Don Chan Widayakum School in Thailand, and that is the thank you for that. A couple of our Globe partners at NASA, Dorian Janney at the Goddard Space Flight Center and Peter Falcon at the Jet Propulsion Laboratory, visited Thailand and did lots of work and presentations for the Globe program when they were there, and they were instrumental in getting this first school on board to start to take soil moisture measurements. We also have the Al-Baroni Elementary School in Israel join us, and we had a couple new schools in the United States. We have the Harmony School of Excellence, the Rutgers Preparatory School, and the Prairie View Academy. So welcome to those schools that joined us in February. And one thing I should note, some of you have asked me whether or not if you've collected data and you haven't put it into the system yet, can you put that data, can you basically, retroactively put that data back into the system? And yes, that is possible, because you can select the date, as you know, when you do the data measurement, select the date and then put that data in. So please do that if you have data that you've collected on paper and haven't got a chance to put that into the Globe system yet. Please take that data and put that in there for the dates that you actually collected the soil moisture samples, so we have all that information. So if we look at this chart, sorry that the text is getting smaller and smaller because we're getting more and more schools, but this is so far the SMAP block pattern data counts for the life of the mission. The 3, Osnovna School of Varesdin with Marina as a teacher is at number 1 with 187 soil moisture measurements, which is just amazing. Bowling Green State University is hanging on to second place with 109 measurements, but I think that at some point they're going to be overtaken because there's lots of schools that are jumping in. Shoemate Middle School in Michigan is at 102 measurements in 3rd place. But some notables is we had a big jump in some of the schools in Croatia. The Kukuljevica, 57 measurements so far. And then the school, Callaway High School has, sorry, it should be the Bosman School in Montana has 70 measurements now. I think I transposed at some point. But thank you all for all the great measurements, and we look forward to the continued SMAP measurements. And it's really, really exciting to just to see all the measurements coming in, and also how the SMAP team at the Jet Propulsion Laboratory with Erica and her colleague Narendra are really looking at the data to you know, to see, to really compare your data to the actual SMAP satellite data, because it's very important data. So thank you all for collecting such data. So that's great. And one other thing in review, SMAP data layer in the global visualization map. As you know, when you go to visualize the data, when you choose the science, you can choose a science data layer, and then you can scroll down and add the SMAP layer to the map. Now, there's one thing happening right now is the legend that you see, the color bar, is actually being reworked to make it make a little more sense. This was the bar that the scientists, put together to look and analyze the data, but for our purposes, we need this data legend to match up a little better. And I know, Erica, if you have any information on that, I know, Erica, this was brought up during a SMAP science team meeting, and this was under discussion.
Correct. It's under discussion, and we'll be updating that soon.
Okay, great. Yeah, because a couple people had questions. Came to me and said, "Hey, this is not matching up to the way we really would love it to." So that's great. SMAP team is working on that, and I know once the SMAP team works on that, they'll be coming to Globe to make that change. But it's really exciting because you can actually go and choose a date that you collected soil moisture data, and you can look at where SMAP was, or the data that SMAP collected on the planet during that time. So hopefully it happened at a time where these swaths here, you see these patterns of soil moisture measurements. This is as the Earth is rotating and as the satellite is moving around the planet, it shows where the satellite soil moisture data has been taken. And you can choose any date for this, and it will bring up the map of the soil moisture data. So it's really exciting stuff. All right, so now we are going to turn it over to Dr. Kevin Chikowski at University of Toledo. Kevin is a Globe Master Trainer, and he and his students have been doing soil moisture collection via the SMAP block pattern protocol, and he's going to give a description and an idea of how they're collecting the data and from their end. So I'll pass it to Kevin.
Hi, everybody. I hope you can hear me. Let me know if you can't.
Yep, good.
Yeah, thanks, Brian, for introducing me. I'm a professor here in the Department of Geography and Planning, and I've been with Globe for maybe 16 years, and I'm a Globe scientist. I'm also the chair of the Globe Science Working Group, and I'm the PI of one of the new NASA CAN projects. We call it Mission Earth. So hopefully you'll be hearing more from our group over the next few years. Our data collection, I should introduce Taj Munir.
Hi everybody, I am Tasminur Rahman. I am here from the last fall as a graduate student. I am from Bangladesh. I am working since this spring for collecting SMAP. Okay, thank you.
So the way we started observations was with my class, my remote sensing class, and I had the students, we all went out as a group. Our study site is over by the river. We had to pick a place where the grounds crew wouldn't be upset if we dug a hole in the ground, right? And so it's maybe not the best place, but it seems reasonable as far as the data goes. It seems reasonable how the moisture is being held by the soil. Anyway, my class went out, then I had my class sign up, and each students, they went out in groups of 2, collected observations. We have a drying oven, which is nice, that we got a couple years ago. And so, you know, dry the soil for probably about 2 or 3 days, and then have the students enter the data. Now, once the class was over, I had a student who was visiting from Germany, from Cologne, Marina Meyer, and she's one of Carl Schneider's students. She's a pre-service education major, and she, you know, basically was like an exchange student to come here to learn more about globe and how we do it in the U.S. So she started taking observations. I suggested to her if she's going to be a globe teacher someday, it'd be good for her to take observations and learn how to do it. So she started, and then she left in January, and Taj Munir took over for her as my teaching assistant. So it's really nice that he's been taking observations every few days. You want to say something about how you take the observation?
So for taking observations, right now I am taking twice a week. For this, I am using sample box, sample can. That's like, first of all, I take the measurements, then the can, then I fill and collect in the cans with the soil in that ground if it is normal condition. So after that, I fill the forms there times, and then I return back to the lab. I take the measurements for the container with the soils. Then I again take the time and put it in the oven. And usually it takes 22 days. That means 48 hours to for drying in the oven. So after that, I again take the measurements and write down in the sheets, and then I update the data in the SMAP Globe website. That's all. Then I recheck in the website for how the data is displayed in the maps and graphs are showing. So in that way, I am doing from last January. So that's all for me. So far I'm doing.
Well, thanks, Tajmir. So one of the things that Tajmir was telling me is that when the soil is really dry, he's had trouble getting the can into the soil. So basically, we've had to take a little trowel and, you know, dig the hole and put it into the can. So I think that's okay as long as he's filling the can up with the soil. Yeah, you know, it's been somewhat dry here. We haven't had a lot of snow, and the ground has been frozen off and on. One of the other things I wanted to mention was that in the class, I did use the SMAP data, the remote sensing data, and we compared, or the students compared lure observations in the field with the satellite observations. And it's, I don't know, I would say surprisingly, they correlated well. So maybe I shouldn't be surprised that they would, but you know, given that we're taking observations near the river, not an ideal spot, maybe not most representative, but it did show, like when there was a rainstorm, our percent soil moisture went up. In our in situ observations, the satellite also showed an increase in soil moisture. We did have the students look at the other globe data and look around the world and compare it to the satellite observations. One of the things they noted was that in coastal regions, the SMAP has more trouble than in more continental regions. of the world. So Puerto Rico, the SMAP was overestimating soil moisture by quite a bit, and I suspect that's the mixed pixel problem with the ocean and the water in the ocean. Interestingly, we are near Lake Erie here, but we were not having that issue with SMAP overestimating the soil moisture. Anyway, that's all.
Yes, Kevin. So to add to what you just said, this is Erica. Absolutely, there are issues with sites that are very close to a large water body, especially Puerto Rico. So if you consider the area that we're looking at, it's about 36 kilometers by 36 kilometers. And so you have a lot of contamination. And we don't expect to have such great correlation on sites like that, like the Puerto Rico sites. So yeah, I'm surprised to hear too that you've had such great matches being so close to the lake.
Yeah. And so anyway, that's all we had, our update.
Okay, Kevin, there's a question on the chat for you from Vicky Gorman. It says, Kevin, when you dry in the oven, do you dry in the container in which you've taken the sample? We dry with 3 heat lamps with the dirt spread out in a meatloaf pan, and it only takes 10 to 15 hours to dry. I'm worried if you are using a drying oven for 2 days, we might not be drying enough, even though the extra drying time does not result in a change in mass. Is there a reason why you put it in for 2 days? Have you seen that works the best?
Yeah, what we've done is take it out, take the canister out, weigh it, put it in for another day, weigh it again, and check to see if it changes. So yeah, after 2 days, the soil moisture in general is not changing. And we do use the regular container. We just take the lid off and place it in the oven.
What temperature do you usually keep it at?
75 to 95 Celsius.
Okay.
Maybe 80.
And there are a couple other comments in the box. Margaret said, we dry in an oven in the collection container, and the most that has taken is 12 hours to dry without any change. Marina says they spread out the samples, they dry faster, and they dry it in the air near heat of radiator. I like that. It's kind of a cool method to do, as long as you don't get much moisture from the radiators. I know some radiators with the release valve can spit out some water and some moisture. So, but if you're seeing that there's no change over time when you're doing this, that's great. There's always teachers are. I love how all the teachers, you know, if they find something's not working to the best of what it should be, that they modify it, but still keep everything intact and how they need to do it. It's excellent. Does anybody have any questions for Kevin? All right. Well, thank you so much. Did you have anything to share? Anything on the screen, Kevin?
No, I was just going to respond to the question about whether the person is drying long enough, 10 to 15 hours.
Yeah.
It's just weigh it, dry it some more, and weigh it again. If the weight doesn't change, then you've gotten all the moisture out you can. That's my understanding.
Yeah, absolutely. Yep. You want to keep weighing that. If you don't see a change in that mass, then you know you've dried it sufficiently. All right. Well, thank you so much, Kevin.
Yeah, Jody has a question about how we compared GLOBE to SMAP data, and yes, we originally used. There was a link from the National Snow and Ice Data Center, I believe, and I was on WorldView where the data was. But now you can go to the GLOBE website. It's Brian, you just showed me. I didn't know that until just now.
Yeah.
That it's one of the layers on the GLOBE website under base layer. So that's pretty cool. It's all right there. You can get your SMAP satellite data, get the student observations, and do the comparison. It's what is it, apples to apples, because it's percent to percent, I believe.
Yeah.
So I think it's okay. It's actually a great exercise. I hope to do it in my teachings this summer. Well, I also noticed that the Globe database right this minute doesn't seem to be showing, the visualization system is not showing the protocols. So something might be wrong with the visualization system right at this moment.
Okay. I see Travis Anderson is on from Globe right now, so let's hopefully you know, if anything's going on with the with Globe website, that you know, he can check into that. That'd be great. Okay. Anything else for Kevin? All right, great. Well, thank you so much, Kevin, for presenting and your student for presenting. Excellent. That's great. I don't know if we need to really cover much, but if Erica has anything else to discuss regarding the SMAP mission, I know most of that was pretty much, excuse me, covered earlier. But is there anything else, Erica, you want to mention about the mission?
Yeah, nothing else to add at this point, Brian. I just wanted to thank everyone for participating so enthusiastically. And I wanted to let you guys know that now we're getting to a critical point where you guys are collecting a lot of measurements. And that's what's really helpful for us, is a time series of measurements where we can see the trends and how well SMAP correlates to the trends that are that you guys are observing.
All right, excellent. Thank you, Erica. And we usually have a Globe program update, but I believe Kristen is unavailable at this moment. So basically, this is, you know, this covers exactly what we discussed. The new you know, on the Globe website, we have, of course, the SMAP campaign page and the blogs. There have been blogs posted off and on. There's been some good discussion in the discussion forums as well. And I just got I saw a note from, let me see here, from Travis, excellent. And he mentions that, I mentioned earlier that the immeasurable soil states were not showing up on the map. And he mentioned to me that the missing or immeasurable data now is available on the Viz map. It's labeled as missing in the legend. So, and the tabular form of the data tells you why it is missing, such as frozen or snow covered, or whatever the choice was you select is immeasurable. So that's awesome. So that data is now showing up on the map, and it's showing up in the Globe system, and the schools are now that is part of their data counts. So that's part of your data counts. So excellent news for that. So that's great.
Hey, Brian, this is
Yep.
Jody. Can you hear me okay?
Yep.
So I'm still a little bit confused. I know we talked about this. I've got the website up right now, and I see that I can put on the SMAP layer on top of the Globe data.
Yep.
But that legend that I was talking about before, that SMAP legend, doesn't seem to be interactive. So I see the scale, but I don't know what yellow represents, for example.
Yeah, so what's happening, that scale is in the process of being changed. It's
okay.
being modified, because that was actually one that was created by the SMAP scientists to as part of when it originally was put up on Worldview.
Right, that's where we were using it off of Worldview just fine, but not here yet.
Yeah, right, and they just took that legend, unfortunately, just moved it right over to the.
Okay, so how is Kevin doing it then? That was my question. So how is Kevin comparing those two if that legend's not working?
No, we did it off of Worldview.
Okay, sure.
So I didn't know it was on, or maybe I didn't remember that it was on the Globe website.
Okay.
For our talk.
Okay, my students are doing it right now, so I just wanted to make sure we have a good technique, and we're using Worldview just fine. But
Okay.
yep.
So hopefully that legend will be fixed, you know, in the very near future, and then it'll match up to, you know, to what you're looking at on the Globe Viz app.
Yeah, that's great.
Yeah. So.
Thank you. That's my only question.
Thank you for the question. That's an important one, because I've had a couple people ask me about that, and that's being worked on. So excellent.
Okay, great. Thanks.
Thank you, Jody. All right, so that's good to see the immeasurable state is up there now. And as mentioned, that legend will be is being worked on as we speak. So one last thing about the SMAP protocol. Remember, as a reminder, if you need a refresher on how to collect your samples, there is the online instructional video. It was done by a summer student at the Jet Propulsion Laboratory. And it's a great, almost 12-minute video, step-by-step, how to do the protocol. And you can just go on into the Globe page, the Globe SMAP campaign page, and you can find that link right there for that. I know a lot of you have probably watched it, but this is just a reminder that it's there if you need kind of a refresher for it, or if you're doing this for the first time. That would be a great thing to take a look at. So any questions on the SMAP soil moisture campaign? I have one more slide, and it's the introduction of a new campaign, but I want to ask for any questions or any comments before we move on to the next slide. And I'll give a second to, if you want to unmute yourself. Okay, so excellent. Thank you all for this. Our next webinar for the SMAP field campaign will be in probably the first week in April. I don't have a specific date down yet, but I will send that out when we schedule that. So on to the next slide. In this slide, I'd like to introduce what's happening as of today. There is a new field campaign that is starting, as I mentioned, today. It's all focusing on El Nino. So as you know, the El Nino event is happening right now globally, and it's a climatic phenomenon that can have impacts on the climate globally, causing flooding, droughts, as well as causing changes in seasonal weather. This campaign, starting today, and I keep on saying that because it might have seemed like to a lot of people that it's all of a sudden, and it is. We got this off the ground pretty quickly because we really wanted to get everybody out there taking measurements and seeing how the El Nino phenomenon is affecting your local environment. And what we've done is we've brought a team together from NASA and Globe and some affiliated universities. Some of the team members are on right now. Dorian Janney from the NASA Goddard Space Flight Center, as well as Kristen Weaver from the Goddard Space Flight Center. Kevin Chikowski, who you just heard from the University of Toledo, is part of the team. And we have Ann Martin. She is our evaluator. She's at the Langley Research Center and a company called SSAI. So we have a great team, and we have a couple from some countries, across the globe as part of this team. So what we're doing with this campaign is we decided we're going to focus on 6 particular protocols, and these are protocols that a lot of people are taking measurements with now. And these protocols are precipitation, maximum minimum air temperature, surface temperature, soil temperature, SMAP soil moisture, and biometry, canopy, and ground cover. And we thought that these would be the 6 best protocols that students can take data, look at how their data, look at their data in their environment, and compare that data to information, weather with weather events, and looking at their data, their weather data in the past, and then looking at global data, climatic data as well. So they can take these protocols, look at how these protocols look at the data from these protocols and how the El Nino phenomenon is affecting these, and then comparing this to the history. They can look at their local area, their environments, their precipitation measurements or surface temperature measurements from their area over the past few years or past 10 years, and compare those that data to the non-El Nino years. So what we're focusing on is we want students to participate by collecting data in at least 2 of the 6 protocols. And we figured we'd love to have schools doing all 6 protocols, and some schools might be doing all 6 right now. But with at least 2 protocols, you have some comparisons you can do. For instance, if you decide to do the precipitation one and the SMAP soil moisture, you can, that lends itself to comparing the data sets and seeing how one affects the other. And then one big part of the campaign push is that we want to have students collecting the data and then extending or expanding their data to see what type of questions they can answer about El Nino, what research projects or virtual science fairs projects they can come up with by just using the data that they're taking during the El Nino event during the with these protocols. So today, later today at 8 p.m. Eastern Time, it's actually 1 a.m. UTC, we will be having the first El Nino Field Campaign webinar. And I'm going to turn it over to Dorian. Dorian Janney is with the GPM mission at the NASA Goddard Space Flight Center, and she is leading the webinar portion of this campaign. And I'll just have her speak for a couple minutes about today's webinar and what to expect in the future in the form of webinar. Webinars, we find, is our greatest way to communicate with you because we have lots of participation and interest. So I will turn it over to Dorian.
Well, thank you so much. And Brian, I see that we both got the memo to dress in orange today.
Yeah.
Well done, in honor of MS Month. Yeah, so we're really excited about launching this this new field campaign, especially with the beginning of March. And we've certainly seen in the Washington, D.C. area the impacts of the El Nino. I've been working with a couple of groups of 3rd and 4th grade students collecting temperature, maximum current temperature, looking at the clouds and precipitation data. And just with using those, very, very easily accessible GLOBE protocols, they have been really excited and paying a lot more attention to what's happening, in the weather and what the changes are in the weather. So tonight, the webinar will start off, we have a series of 10 webinars, and tonight's webinar will kind of set the stage. Tonight will be all about the science behind the El Nino. So most of the time, a half hour of the program tonight will be having a NASA scientist who studies the El Nino, Veronica Nieves, will be presenting on what the El Nino actually is. What causes an El Nino? How do you know when it's happening? What are some of the impacts that you expect are going to be happening in different parts of the country? And just kind of setting the background, telling us what the background science is behind this El Nino phenomena. And then Brian will take a couple of minutes at the beginning to let people know about this campaign, a little more in depth about the things that he was talking about a few minutes ago. I'll share some of the experiences that I've had with my little 3rd and 4th graders on collecting this data and getting them excited. And then Kristen Weaver will give us an overview of the website, which she's just done a phenomenal job of setting up. Then every week for the month of March, we'll be having a webinar. We do apologize that it's 8 to 9 p.m. at night Eastern Standard Time. We apologize to the folks that are in other locations in the country for whom that's not very easily accessible. What we are going to do is I will have a live office hour 2 days after every one of our webinars. 2 days later from 8 to 9 a.m., I will have an office hour so that hopefully you will have had a chance to have seen the archive. We'll put the archived webinar out right away. Hopefully you will have had a chance to see it. And if you have any questions, I will have this room set up that I will send the link out for, and you are welcome to just come in, ask questions, and that will be at a better time for most other people in other locations around the world for whom 8 to 9 p.m. Eastern Standard Time is not the best time of day. So we will be sending that out and letting people know about that office hour. Then we'll be going on, like I say, every week. Next week we'll talk about we'll go from having talked about the science behind the El Nino to looking more specifically at this student field campaign, what we're going to be doing with it, how we'll use the data. We'll also have some of our Globe teachers who use the different protocols share in, like Kevin and his student did, and give us a feel for how they are collecting this data. Then on March 15th, we'll be looking specifically at El Nino data collection and talking about about the 6 different protocols that we're using and how you collect that data. And then we're going to go every 2 weeks after that, and we'll be looking specifically at those protocols. So talking about best practices, how you do the protocols, and always having a NASA scientist come on and talk about the ways in which NASA satellites are collecting data, for example, surface temperature and soil temperature, and how those data are used in different types of research that they do. So these webinars will take us through, through May 3rd, going over every 2 weeks, and we'll go over the different protocols. On May 17th, we'll be talking about the El Nino again. We'll be looking at what actually happened during the El Nino season. It's anticipated that by May, El Nino conditions will start to neutralize, and we'll kind of get into that neutral zone. So we don't anticipate that the El Nino conditions are going to be lasting throughout the entire field campaign, but we want to have students start to collect this data and look at it and be aware of what typical weather conditions are, and then compare and contrast what normally happens using climatic data to what they're actually seeing in their community. There you have it.
All righty. Well, thank you, Dorian. And
you're welcome.
And one thing I should mention is that this campaign, if you are already taking measurements via the protocols, you are part of this campaign. We just hope that you join us on each of the webinars, and at some point, we might call on you as a teacher representative to discuss how you've taken some of the measurements in these protocols. We've been trying to get some teacher names together, and I have lots of ones in my mind for when we talk about soil moisture. Dr. Podas, Erica Podas will be on for the soil moisture webinar when we talk about the SMAP protocol. But also there's several teachers I know that I really want to call on who can hopefully be part of the webinar and share your experience, as Dorian mentioned, best practices in taking these protocol measurements. So I think that'll be some exciting stuff. So, your inbox might get a ping from me in the near future asking if you'd be available to do this. And, we'll set all this up with Dorian. So please join us tonight. You can see on there, this is the actual direct link to the webinar tonight. But what you want to do, if you haven't already, and I'm sure a lot of you have registered, is you can actually go onto the Globe website, and the El Nino campaign is up there. It's up there live, and it'll be a link there that says to join to register for the webinar.
And for those of you who can't join us tonight, I'll chat with you in the office hour on Thursday.
Yep. And so I also should mention that, as you know, the SMAP field campaign has been going on since October 1st, and it essentially will end on April 30th of 2016. And what that means is that the specific SMAP campaign will end, but the El Nino campaign will continue. So that is kind of the next phase of the SMAP one. We're taking it away from getting a very mission specific to multiple missions, I should say NASA missions that are part of the El Nino campaign. So if you're taking the SMAP data, keep taking that data, because we need that data, and it's part of the new Globe El Nino campaign. So we're excited that it's actually the SMAP campaign is blending into, and hopefully seamlessly move into the El Nino campaign. And please also stay tuned for new campaigns in the future. You know, we're always thinking, we're always working on the best campaigns, and we have a campaign team at NASA and Globe that are working on to see what the most beneficial campaigns will be, you know, for the next 5-10 years. So we've been working on that. So are there any questions about the El Nino campaign? And tonight, as Dorian mentioned, is the first, we mentioned the first webinar, 8 p.m. Eastern Time, 1 a.m. UTC. So we hope to see a lot of you there. Hope a lot of you registered. I know there's some comments in the, there's some questions in the comment section about the campaign. So thank you so much, everybody, for all the hard work that you've been doing with collecting the SMAP soil moisture data. And does anybody have any parting questions or questions that you really need to ask any of us?
This is Marcos San Luis.
Hello. Hi, Marcos.
Hi. Do you need to be retrained by a master trainer on site for this new campaign?
No, you don't have. You do not have to be retrained for that. If you know, if you're trained in those protocols, that's fine. It's you do not have to be retrained for that.
Thank you.
Right, and you see that Dorian did mention, she said, please invite any teacher to join our El Nino webinars. It's not just for Globe teachers. So it's really to get that interest in understanding El Nino and how, you know, how NASA really looks at it and how you can help that. You can help by taking the measurements. All right, anything else? If not, I will end this meeting. I will stop the recording in a second. Anybody else? All right. Remember, next one will be probably the first week in April. And you know, because I send out a lot of emails reminding you about things related to this soil moisture campaign. So thank you all, and look forward to seeing a lot of you tonight on the webinar. We have a great number of people signed up, so it's going to be a big one. So hopefully you'll see a lot of people. We'll have some great results and some discussion tonight. So thank you all, and we will talk to you either tonight or in a month, or Dorian will talk to you during her virtual office hours. So thank you so much. Take care.